Okay, MAT112 Chapter 2, Introduction to Set Theory. How does one begin to understand the world in which we live? People, insects, clothes, foods, landscape, plants, buildings, etc. A whole world is divided into groups of things, which we can call sets. A set is a collection of objects, that's all. And studying sets from a mathematical standpoint is a good opportunity to see how math is used in our world. Vocabulary is important to writing, defining, and understanding sets. So their point is that how do you start looking at anything in this world? Well, you start by grouping it. And we have all kinds of ways to do that. I want to talk about set theory, which is a collection of objects for a set. And when you create that set, you want it to be well defined based on facts and not opinion. So try to be as specific about what is in the set as possible. People that have many cats, how many is many? I mean, that's kind of vague. Is it people that have two cats, people that have one cat? But try to be a set should be something that you can be sure about. Number 3, it said each object in the set is called a member of the set or also an element. The roster method of writing a set uses parentheses. Some people call that set notation. If it's like 1, 2, 3. So maybe this set are the numbers equal to or less than 3, not including 0, that kind of thing. 1 is an element or a member of the set. So is 2, so is 3. When you're putting a bunch of elements together in set notation, you want to have a comma separating each item. And listing it this way is considered the roster method. Okay. Something is either in a set or not in a set. You can say that 1 is in the set above, and 0 is not in the set above. So these are the symbols for in the set, or is an element of the set, or not an element of the set. Order is important. Unimportant. I like to say important because it's a good habit to write, if they're numbers or letters, to put it in order so you can find things. But technically, even in your homework, you should be able to put it in any order. They're either in the set or they're not in the set. But make sure that you're listing it only once. There's never a duplicate. There's not, like if you're listing colors, there's not yellow, brown, green, yellow. Yellow can't be in the set twice. It's either in it or it's not in it. But order is, in general, unimportant. Sets are typically named, but with a capital letter. This could be set A, set B, set C, whatever. They get a label so they can talk about sets together. Number 8 says the number of objects, members, elements in a set is called the cardinality of the set. So the set I made up there has a cardinal number of 3 because it has 3 members in its set. A set is called finite if the set has no elements or its cardinality is a natural number. Sets are finite or infinite. So I have a finite set above that I made, 1, 2, and 3. Its cardinality number is 3. But if you have the numbers above 3 in a set, it's going to go on forever. So it would be an infinite set. Okay. And apparently you can have a set that looks like this, and that is an empty set. There's nothing in it. So that would be a finite set. So nothing or a natural number. So a null set, like I just drew, can have the brackets with nothing in it, or um, it looks like a zero with a line through it. That means there's nothing, or it's an empty set. There's no members in the set. So A could be an empty set. Okay. Excuse me. Forgot to move it up. There we go. Let's see. Number 11, two sets are equal when they contain identical elements. Identical elements, but two sets are equivalent if they have the same number of elements in there, and can be put in a one-to-one correspondence. So if I had 6, 7, 8, that would be an equivalent set, but not an equal set. Okay. Set builder notation. That looks a little different. It has brackets and a vertical bar. We're going to look at that on the next page. Here, right here, I have, let's pick something out. This is a roster form of a set with these 4 months in them. And this is in the roster method. This is the set builder notation. It has the same brackets. It has a variable with a line in between, and then it tells you what the variable is. It is the months starting with M or A instead of listing them like the roster does. Okay. So let me go back at the top here. Here's other examples. Counting numbers are natural numbers, they referred to. Uh, they start with 1 and go up. That's why the definition is 0 or a natural number, because natural numbers don't include 0. Think cavemen, 1 rock, 2 rock, 3 rocks. They didn't really need a word for 0 rocks till later. So these are considered natural. If you don't have anything, you can't count it, I guess is a good way to think of it too. So these are the natural numbers or counting numbers. So a set of n is an infinite set. This one up here, because see these little dot, 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 these 3 dots at the end mean it goes on forever. So it's an infinite set. It doesn't have a fixed cardinality. Okay. So a set can have a natural number of 109 in the set, and that's still a natural number. Okay. So we're just, like I said, just vocabulary here. I did not know that 3 dots together was, what's that, ellipsis? Did not know that word. I promise not to ask you that word, but that's interesting that there's a word for 3 dots that mean etc., right? Okay, so if I was looking at months with 30 days, I can make a roster listing. April, June has September. I can't remember there's a saying for that. September, November. Those are months with 30 days anyway, in a roster method. Cardinal number for the set M. Notice this says set equal, so this can be called the set labeled M. Okay, so the cardinal number for M is 4. It has 4 members. Okay, so cardinal number for M is 4 is kind of like that. Number of members in set M is 4. N of M is 4. Okay, that's kind of like functional notation, but let's see. December is not an element of M. So December is not in the set of M, so we can write it this way. That's how you read this. December is not an element of M. Months with 40 days is an empty set, or a null set is another word for empty set. The rest of it on here. And then here's another set I'm labeling, calling A. So sets A and M are well defined, right? Months starting with M or A. This one was months with 30 days. That's very definitive and factual. Okay. M and A are equivalent because they have the same number of members in their set, but they're not equal because the members are not identical. Okay. Another set called labeled P, a car in California, believe it or not, is well defined. It's different than a cat in California, a tree in California. It's a car. Is it a car or is it a truck? So it's a car. So that's considered well defined. But W says tall students in class. Well, what do you think is tall? It's not defined. Is it somebody over 5 foot? Is it somebody over 6 foot? That kind of thing. So be careful, slow down with those in the homework. Thank you.